This is for Year 12 Methods. It's the 2018 Chapter 910 topic test question number 3. State the equations of the lines that are tangential and perpendicular to this hyperbola. I notice that part B is also of the same hyperbola and part C is the same hyperbola. So to save typing it out all the time, I'm going to define it. So over here I've got 3 on top of x plus 2, and I am plussing 4, and I'm going to select it, interactive define, and call it f of x. Okay, and pick up f of x and put it on a new line. So I wish the tangent at x equals 1. So if I select that, interactive, calculation, line, tan line, at x equals 1. Okay, and my answer is y equals negative x on 3 plus 16 on 3. And the second part of the question said find the perpendicular. So interactive, calculation line, normal at x equals 1. Okay, and I get y equals 3x plus 2. Noting that my gradient is 3 and this gradient's negative 1/3, so pretty happy about that. Okay, part B, state the equation to the tangents that are parallel to this line. Well, this line is y equals minus x plus 5, therefore my gradient has to equal negative 1. So I'm going to take f of x, I'm going to take its derivative, set the derivative equal to negative 1, and solve for x. That gives me two answers. That gives me, I want the tangent at x equals negative 2 minus root 3 and at x equals negative 2 plus root 3. So I'm just going to take my negative 2 minus root 3 and copy it. Then I'm going to pick up my f of x. Whoops. Pick up my f of x, select it, interactive, calculation, line, tan line, at x equals, now I'll go paste, and that gives me y equals minus x minus 2 root 3 plus 2, and if the other one was positive root 3, execute, gives me y equals minus x plus 2 root 3 plus 2 as being the second equation. And lucky last, part C, tangents that also pass through the origin. So I have a special rule about that. I'm looking for the tangent that passes through the origin. I want to have f of x equals f of x on x. So if I take f of x, okay, so I want the derivative equal to f of x over x. So I've got that here. So I'll interactive advance solve for x. Okay, so that gives me two answers where x will be those values. So I've got x equals negative 11 on 4 minus root 33 on 4, and x equals minus 11 on 4 plus root 33 on 4. And I'm looking for the tangent at that particular point. So if I take f of, I'll copy this first, copy, take my f of x, put that into a new line, select it, interactive, calculation, line, tan line, at x equals, paste that in, answer, simplify. There we go. So I'm literally going to write that as it is. Y equals negative x all on 2 of negative root 33 plus 7 and if I also have the positive root 33, that gives me an answer of y equals negative x all on to root 33 plus 7. And of course, since these tangents go through the origin, I don't have a y-intercept in the equations because they go through the origin.